Number one on these TSI practice problems says, if there are 2.2 pounds in 1 kilogram, how many pounds are there in X kilograms? And this is basic right here, and what this is referring to is the type of calculator you'd be allowed to use on this particular problem. Basic meaning your regular 4-function calculator, so not a scientific, not a graphing, but just really one that can do your basic arithmetic. So the setup here is we want to set up a proportion that compares two equal ratios. So in other words, we're going to set two fractions equal to each other, and the setup for those fractions is on one side of the fraction, either the numerator or the denominator, you want to put pounds, and on the other side, you want to put the other unit, in this case, kilograms. Now, it doesn't really matter whether or not you put pounds on top or on bottom. This can switch, and that's fine. Just make sure that when you're setting up the other two, the two fractions, that you're consistent. So either pounds should be in the numerator in both fractions or in the denominator in both fractions. So the setup is kind of like this. We want to say we want to have two ratios or fractions that are equal to each other to make this proportion. And it says there are 2.2 pounds in 1 kilogram. Put 2.2 pounds here in 1 kilogram, and I'm just going to, you know what I'm going to do? I'm going to say 1 kilogram. And out to the side here, I'll just say pounds and kilograms, just to keep track of what we're talking about. So the next ratio will be, how many pounds, so this is our question mark, that's what we're trying to find, are there in X kilograms? So instead of a question mark here, I think what I'll do is just put pounds, okay? And then we'll just solve for this. If you want to just use one variable like L, that's fine too. But I just want to make sure that we know what it is we're trying to find. So we're trying to solve for the pounds in terms of X. Notice how X is part of all these solutions. All of these expressions are written in terms of X. So we're just going to solve for X here. Now we can use something called the cross products property. Let me just break that down for you. Cross products property. Sometimes it's known as cross multiplication. But basically what it says is if you've got a proportion, you've got two equal ratios, so like A over B and say C over D, you can rewrite this by multiplying A times D. So multiply the numerator of one fraction by the denominator of the other, and that will be equal to the product of the other numerator times the other denominator. So we have AD equals CB, right? And so that's kind of what we're going to do here. This cross products property, we're going to multiply 2 times 2 by X, and then 1 times our pounds. Now 1 times anything is just going to be the anything. So 1 times the number of pounds that we're looking for is just going to be the number of pounds. You could stick a 1 in front of it, but you don't need to. And then that's going to equal 2.2 times X. And that's basically it, all right? The number of pounds in X kilograms would be 2.2 times that number. Now, you can get away without doing any of this algebra if you just kind of read it carefully. It's saying there's 2.2 pounds in each kilogram. So if you have X kilograms, you would have to multiply 2.2 by that many kilograms. So this one really isn't too bad. This is sort of the algebra behind the reasoning, but you can just kind of reason your way through this, and our answer here is B. Hey y'all, welcome back. Number 2 on these TSI practice problems says, the bar graph above shows the number of customers who shopped at a store Monday through Thursday of 1 week. Okay, and before I go any further, I just want to make it very clear how many customers who shop there. In hundreds. So on Monday, there was 200 customers. I'm just going to make a little note here, 200. On Tuesday, it looks like you can't tell exactly, but it looks like it's halfway between 2 and 3. So we're just going to estimate here 250. Wednesday is back down to 200, and it looks like on Thursday is their busiest day. We get 400. Okay, let's move on. If the number of customers on Friday was 1/5, what was a 1/5 increase from the number of customers on Thursday, how many customers shopped at the store on Friday? So on Friday, we have a 1/5 increase. So first, let's figure out what is 1/5 of 400. What is 1/5 of 400, right? And since there's a 1/5 increase, what we'll do is we'll just add that number to 400 and we'll get our answer. So to figure out what's 1/5 of 400, we're just going to multiply 1/5 times 400. Now this does say basic right here, so you will be allowed to use a 4-function calculator. So you should be able to do this. 1/5 times 400 would be the same thing as, say, 400 divided by 5. Okay? And so we're going to get, what would that be, 80. So 80 is 1/5 of 400. If I multiply this by 5, I should get 400. So 80 is 1/5 of 400. So what we need to do, since we have a 1/5 increase, okay, so we're going to add the 400 on Thursday to the increase, 80. So on Friday, there is a 1/5 increase from Thursday. Okay, so to interpret that, we're going to say that we started with 400, and then we're going to add the 1/5 increase, which is 80, and that's going to give us 480 customers. So that's our answer. Let's go ahead and make sure that's one of the answer choices. We do see it here. It's letter A. So that is it for number 2. Hey y'all, welcome back. Number 3 says, last year a bakery sold W loaves of bread. This year the bakery sold 3 more than twice the number of loaves of bread it sold last year. If next year the bakery plans on selling twice the number of loaves of bread sold this year, how many loaves of bread does the bakery expect to sell next year? Okay, so last year we sold W loaves of bread. So last year, W loaves of bread. And then this year, I'm going to keep track of this as I read it. This year, the bakery sold 3 more than twice the number of loaves of bread sold last year. So if it was twice the number of loaves of bread as last year, it'd be 2W, but it does say 3 more than twice the number of loaves of bread. The 3 more than is going to be a plus 3. Okay, so that's the expression that will represent how many loaves of bread we sold this year. And then finally, we're talking about next year. So next year, the bakery plans on selling twice the number of loaves of bread that it sold this year. We already know how many loaves of bread it sold this year, which is 2W plus 3. So next year, it should be twice that. Okay, so twice that would be like 2 times this year, whatever we got for this year. Now, this year, we already know how many we had, right? It was 2W plus 3. So instead of just writing this year, I'm going to write 2W plus 3. And that's that many loaves of bread. So this is going to be our answer, but as you can see, none of the answer choices look like this. So we do have to do a little bit of algebraic manipulation here. Specifically, we're going to distribute the 2, okay, and that means we're going to multiply 2 by both 2W and 3. So 2 times 2W is going to be 4W. And then 2 times 3 is 6. This is going to give us the simplified form of the expression. So it's this many loaves of bread. So 4W plus 6 is our answer, and we can see that that's answer choice D. Number 4 says, if 7p minus 4 equals 8, then what is the value of p? So here we're just solving a linear equation. We have 7p minus 4 equals 8. and there's no distributive property to do here, no like terms to combine. So we're just going to move on to our properties of equality. The first property of equality that we're going to use is going to be the property of addition. We're going to add 4 to both sides to get rid of that -4 on the left-hand side. Ultimately, what we're trying to do here is isolate p. So any numbers that we see on the same side of the equation as p need to be dealt with. Right? We need to get rid of this -4. So to get rid of this -4, we're going to add 4, and our addition property of equality says that if we do add something to one side, we have to do it to the other. Okay, so after I add 4 to both sides, it's going to give me 7 times p equals 12. Is that right? Yeah, 8 plus 4 is 12, good. And then so we have 7 times p. So the way that we're going to get rid of that 7 is we want to do the opposite operation. If this is 7 times p, we want to divide both sides by 7 to get rid of that 7 on the left-hand side. So after we divide both sides by 7, that's going to give us p equals 12 sevenths. Can't really reduce that, so that's just going to be our answer. And it looks like we do have that as an answer choice. So the correct answer for number 4, it looks like it's going to be C. That's it for this one. Hey y'all, welcome back. Number 5 says, running at an average rate of 6 miles per hour, how many minutes would it take Kyle to run 3 miles? Well, first we have to know that there are 60 minutes in 1 hour. Okay, so it's just going to be assumed knowledge at this point. Okay, so if he's running at a rate of 6 miles per hour, how many minutes would it take him to run 3 miles? Let's just stick with hours for now, and we'll convert it to minutes later. So we're going to set up a proportion here. We're going to relate the miles to hours. So if at the beginning it says running an average rate of 6 miles per hour, they run 6 miles per 1 hour. We want to know proportionally how many hours is it going to take for him to run 3 miles. So as you can see here, the scale factor is just going to be to divide by 2. So it's pretty obvious what our answer is going to be. But if you want to use the cross products property to solve this, what you would do is you would multiply each numerator by the other denominator and then set those two products equal to each other. Again, if you want to look up more information about this technique, this is using the cross product property. Right? And feel free to Google that and find some more information about it. But basically, we want to cross multiply these two ratios. So we have 6 times, and this question mark, I'll call that X for now. Okay, maybe we'll use X instead of question mark. X miles. So we have 6 times X equals 3 times 1. Okay, 3 times 1. Now, 3 times 1, as you should know, is just 3. And so to solve this, we would divide both sides by 6. So we get X equals 3 over 6, which is 1/2, or 0.5. So basically what this means is, in terms of hours, it would be a half an hour. Okay, so the number of, this should be hours. Sorry about that. This number right here should be 0.5 hours. Now the question is asking how many minutes is that? Okay, so if 60 minutes is an hour, which it is, not sure why I said it there, but if 60 minutes is the same as 1 hour, then we could say that 30 minutes is the same as half an hour. And so our answer here will be B. That's it for number 5. Hey y'all, welcome back. Number 6 says the dot plot above identifies the number of pets living with each of 20 families in an apartment building. What fraction of the families have more than 2 pets? Okay, so we want, first of all, there's a couple things to note here. First off, I'm going to just give a number here instead of having to count dots, because that's going to be annoying to have to keep counting dots over and over again. So let's go ahead and just like count the dots here first. So I see 0 families, I'm sorry, 4 families have 0 pets. 4 families have 0 pets. Yeah, I guess this is, go ahead and put pets down here. Put families and pets. Okay, the families that have 1 pet, 1, 2, 3, 4, 5, 6, 7, looks like there's 7 of them. Families with 2 pets, 1, 2, 3, 4, 5. Families with 3 pets, 1, 2, 3, and 4 pets. Gee, a lot of pets. There's just 1 family. So it says how many of the families have more than 2 pets. So really, we're just looking at 3 and 4 here. Now we can see there's a total of 4 families that have more than 2 pets. Let me make a note of that. 4 families have more than 2 pets. This is not asking exactly how many families have more than 2 pets. It's saying what fraction of all the families. So we need to also count how many total families are we actually looking at here. So we've got 4 plus 7 plus 5 plus 3 plus 1. And let's see, what would that be? That'd be 4 and 7 is 11, plus 5 would be 16, 17, 18, 19, 20. Oh, you know what? They told us 20 families. I didn't have to count all that up. Sorry about that. But yeah, there's a total of 20 families. At least we have it confirmed. So 20 families total. All right, so we want to know the fraction, right, which is going to be 4 out of 20. So all we really need to do here is just reduce this fraction, 4 over 20. To reduce a fraction, you need to divide both the numerator and the denominator by whatever the greatest common factor of both of those numbers are. And in this case, it'd be 4, because both 4 and 20 are divisible by 4. Now, 4 divided by 4 is 1. 20 divided by 4 is 5. So 1/5 of the families have more than 2 pets. Our answer is B. And that's it for number 6. Hey y'all, welcome back. Now, there are some geometry problems on the TSI, and here's one example. We've got a cylinder. It says the formula for the volume of the right circular cylinder is shown. You won't have to memorize this for the test. Really, there'll be very few formulas that you really need to know to be able to be successful on this. This is not one of them. You don't need to memorize this one. But anyway, it says R, which is the radius, is 2b. Okay, I might make a note of that here. R is 2b. B or not 2b? It is 2b. Okay, and then scrolling back down here, it says the height, or h, is 5b plus 3. Okay. What is the volume of the cylinder in terms of b? So really, this is just going to be a matter of us substituting these two expressions into the volume formula and then probably simplifying. So let's start here, and we'll say that volume is pi r squared h, okay, times the height. So pi times the radius squared times the height. And let's go ahead and substitute in our expressions in terms of b. We really don't need the picture here now that I'm thinking about it, because all we're going to do is just substitute. Let's just copy and paste this. For r, we're going to write 2b. Make sure you put that in parentheses. That could be a place where most people get it wrong, I would think, is forgetting the parentheses there and only squaring the b. But you got to square the 2 as well. Then for the height, that's 5b plus 3. Okay. So at this point, we've got our expression in terms of b, but notice how none of the answers kind of look like this. And that's because all of these have this term being distributed into the set of parentheses. Now, before I distribute this, I think what I want to do is actually simplify it a little bit, okay? So 2b squared would be 2b times 2b. 2 squared is 4, and b squared is just b squared. Now, usually you'll write the pi after the integer coefficient here, so I'm going to just move this pi over, and I'm allowed to do that because multiplication is what we call commutative, and the order doesn't matter. A times b is the same as b times a. So now I've got this term that I'm going to go ahead and distribute. So now I'm ready to do the distributive property here. I'm going to take this entire term, it looks pretty big, but I'm going to multiply that by both 5b and by 3. Oops. Okay, so 4 times 5 would be, let me just delete all this. 4 times 5 is 20. There's nothing to multiply the pi by, so it's just going to remain pi. And then b squared times b is going to be b cubed. That's the first term. And then the second term is what I'll get when I multiply 4b squared, 4 pi b squared by 3. 4 times 3 is 12, so I get plus 12 pi b squared. All right, that should be my answer. Not a whole lot more that I could do to simplify this. I'm really not even seeing anything. So let's see if our answer choices agree. And yep, our answer choice is right here, choice B. Hey y'all, welcome back. Number 8 says Richard bought 3 slices of cheese pizza, 2 sodas for $8.75. Jordan bought 2 slices of cheese pizza and 4 sodas for $8.50. How much would an order of 1 slice of cheese pizza and 3 sodas cost? Okay, this is a pretty tricky problem. This might be the hardest one on here. We'll see if we get any harder than this. But what we need to do here is write an equation for everything that Richard bought, and then write an equation for everything Jordan bought. Use that system of equations to figure out what the cost per cheese pizza and cost per soda are, and then we can answer the question. So for Richard, maybe I'll label this to make it a little bit clearer where I'm coming up with this. We have 3 slices of cheese pizza, so I'm going to call that 3C plus 2S, so 3, or maybe I'll use P instead. So 3 pieces of pizza, 2 sodas, and that's going to equal $8.75. Then for Jordan, we have 2 slices of pizza and 4 sodas for $8.50. So this is a system of equations, and there's several ways to be able to solve this. But I think what I want to do is use substitution here. So I'm going to try to isolate this S in the first equation so that I can use that equation and plug it into the second one. Okay, so let's go ahead and do that. Let's solve for S here. The first thing to do, solve for S. Let me just go ahead and maybe rewrite this a little smaller here. All right, I'm going to subtract 3p from both sides. Okay, that's going to give me 2s equals negative 3p, or maybe to make it simpler, 875 minus 3p. Then I'm going to divide both sides by 2. This is going to give me some pretty ugly decimals, but this is just the way it goes sometimes. So dividing both sides by 2, I'm going to break out the calculator here. You do get a basic 4-function calculator on this one. That's why it says basic. This has nothing to do with the difficulty of the question. It just means you don't need a graphing calculator to do this one. We need to do 875 divided by 2. That's 4.375. And then 3 divided by 2 would be 3/2, but since we're working with decimals here, I'm going to go with 1.5. And your calculator can verify that for you. So now that I have an equation for s, where s is isolated, now what I can do is I can take this expression for s and substitute it into s for the other equation. Then what I'll have is just a single equation that I can solve. All right. I'm going to rewrite this equation 2p plus 4, and then instead of s, I'm going to write 4.375 minus 1.5p, which is the expression that we just said equaled s, equals 850. And what I can do here is I'm going to solve this equation for p. Okay, I'll go through my normal solving steps. It'll take a few steps, but we'll get there. And then once we figure out the cost per pizza, we could plug that in here and figure out the cost for the soda. Okay, you could actually use any of these equations that we had over here, but this one in particular has the s already isolated, so then we would just have to type this into the calculator. This is going to be definitely preferable. All right, so here I'm going to distribute the 4. Again, using a calculator, especially with all these decimals, would be advisable. All right, so 4 times 4.375 is going to be 17.5. And then 4 times 1.5 is going to be 6. So that'd be minus 6p. Scroll down a little bit. Okay, so now we need to, now that we've used the distributive property, we're going to combine our like terms. Means we're going to combine 2p and negative 6p, get negative 4p. Then we're going to subtract 17.5 from both sides. That's going to be negative 4p equals, and I'm going to check this in the calculator, 8.5 minus 17.5, negative 9. And then dividing that by negative 4 is going to give me $2.25. So now we at least know part of our answer here. Okay, we know that the pizza, the cheese pizza, costs $2.25. The per slice, I don't think it really, yeah, per slice. All right, now that we have the cost for the cheese pizza, we can find out the cost for the soda. I'm going to take this number, just found, right here, this is P. I'm going to, again, substitute. That's why the name of this technique is called substitution, by the way, because you substitute twice. Plug it in here, and we'll get our S value, which is the cost of a soda. So S is going to equal 4.375 minus 1.5 times 2.25. And let me bring that over so you can actually see it. So I'll just maybe scroll down a little bit further. All right, and yeah, we'll just need to put that in the calculator. Let's go ahead and do that. 4.375 minus 1.5 times 2.25. All right, something didn't go right here. Let's see here. 1.5 times 2.25. Okay, we have, that's 3.375. So yeah, so 4 minus 3 would be 1. Okay, so the sodas are $1. Right, so let's go back to our conclusions here. The cheese pizza costs $2.25 a slice. Sodas cost $1 on the exactly per soda, I guess. Yeah, per soda. All right, so the question is, how much would an order be with 1 cheese pizza and 3 sodas? Okay, so we'd have, change colors here just to kind of differentiate what we're doing here. 1 slice of cheese pizza and 3 sodas equals what? Okay. So we know that the cheese pizza costs $2.25. So 225 times 1 is going to be 225. And then $3 per soda is going to be plus 3. So that's going to equal $5.25, which is going to be choice B. All right. I told y'all we were going to have a hard one. So there you go. There's the hardest one, I think, on here, at least so far. And that's it for number 8. Thanks for watching. Y'all have a great day. Hey, y'all. Welcome back. Number 9 says, if 5c minus 2 equals 3c, then what does 24c equal? All right, well, if 5c minus 2 equals 3c, let's solve this for c and then see what our answer is. Okay, so we're going to subtract 5c from both sides here. So my work here, minus 5c on both sides. I'm trying to isolate c. So 3c minus 5c is going to be negative 2c. So we get negative 2 equals negative 2c. And if I divide both sides by negative 2, get c by itself. Negative 2 divided by negative 2 is 1. This tells me that c equals 1. Now this is asking, what is 24c? Well, 24 times 1 is just 24. So our answer is D. This was c equals 2, it'd be 48. It'd have to be something like a half to be anything smaller than that. But yeah, so that's it for number 9. Hey y'all, welcome back. Number 10 says in the xy plane, the slope of the line y equals mx minus 4 is less than the slope of the line y equals x minus 4. Which of the following must be true about m? Okay, so if you have an equation that's in this format, this mx plus b format, the slope is going to be the number that is the coefficient of x. It's going to be the m. This is the slope. Now, for the equation that's given, y equals x minus 4. You do not see a number in front of the x. There is an assumed 1 here. So if it's saying that mx minus 4 has a slope that's smaller or less than the slope of this, that means that this slope, this m value, must be smaller than 1. And so our answer is C. There's really not much more to it. You just have to understand, I guess, what it's asking for. And also have a good understanding of this slope-intercept form of a linear equation, y equals mx plus b. Well, that's it for number 10. Hey y'all, welcome back. Number 11 says a history class is made up of 12 10th graders and 9 11th graders. The 10th graders averaged 77 on the midterm exam, and the 11th graders averaged 91 on the midterm exam. What was the average grade on the midterm exam for the entire class? Well, we only have a total of 21 students, right? So, 12 plus 9. So we have a total of 21 students, total of 21 students. And so what we need to do is we need to average all 21 of their grades. Okay, so to find the average, let's write this out. Average is equal to the sum, or maybe I'll write this as a fraction here, equal to the, I'm not sure how I'm going to do that. Maybe not. We'll say the sum of all the grades divided by how many grades there are, and in this case, that would mean the number of students. Total number of students. And we want to divide these. Okay, so we already figured out the total number of students is 21, so we know what our denominator is going to be, but we need to find the sum of all the grades, and that I think is really the hard part here. The hardest part here. So it says there are 12 10th graders and their average was a 77. But we could basically say that each one of them got a 77 and still have the same average, right? So we're going to multiply 12 students by 77, right? Because each one of them, you could say, got a 77. Not that they did, but their average was a 77, so it would be the same thing. You'd have the same average if they were all the same. Saying that right? I think so. And the 11th graders, there were 9 of them, so we're going to add 9 of these 91. Okay, it looks like the 11th graders are doing better than the 10th graders. And we will divide that by the total number of students, which is 21. You do get a calculator on this, so you really shouldn't get this wrong if you set it up correctly. Let's break this down one step at a time, though. 12 times 77 is going to be 924. And then 9 times 91 is going to be 819. If I add those two together, I get 1,743. Right? Last step here is I'm going to divide that by 21. Again, you could put all this in your calculator at once. Move that over so I'm not in the way here. But I'm going to put this in the calculator now. 1,743 divided by 21 is going to give me 83. All right, that's my answer. And I see I do have an 83 answer choice, so that makes me feel pretty good about my answer. It's answer choice B. That's it for number 11. Hey y'all, welcome back. Number 12 says, which of the following is not equivalent to 3x minus 12 times x plus 4? So one way you could approach this, and you can do this a lot when you're trying to compare expressions on a multiple choice question, is just to pick some value for x, substitute it in here. So for example, let's say I pick the number 2, right? And I input all this in my calculator. I say, all right, well, what's 3 times 2 minus 12 times 2 plus 4? So I just replaced x with 2. I can put that in my calculator, and what would I get here? 2 times 3 is 6. 6 minus 12 would be negative 6 times 6. I get negative 36, right? So one way how I can check to see whether or not these are going to give me the same answer is just plugging in that same x value that you choose. Pick a small, easy to work with number, and see if I get the same thing. So if I plug in 2 here, and I plug in 2 here, and all this, I can check. Make a quick little check to see whether or not these are equivalent or not. Now, algebraically, another way we can approach this is notice how this first binomial here, this 3x minus 12, that actually has a greatest common factor, meaning both 3 and 12 are divisible by the number 3. So what we can do is something that is kind of like doing the distributive property, but in reverse, and factor out that greatest common factor. In other words, divide out that 3 and go from there. So if I factor out that 3, I'll have 3 times x minus 4 times x plus 4. Okay, so I'm looking at these answer choices. It doesn't really look like any of them, so I'm going to keep going. From here, I can multiply these two together. Okay, so I can use FOIL or the distributive property. Essentially what I want to do is just multiply x times x, and then x times 4. Okay, so I'll start with that. So 3 times x is going to be x squared. X times 4 is going to be plus 4x. But I also need to distribute the second term in the first binomial. This would be the I and the L in FOIL, if you're familiar with that. So negative 4 times x and then negative 4 times 4 would give me minus 4x and then minus 16. So here we can combine our like terms and notice how 4x minus 4x is 0, right? So these are just go away. And so now we have x squared minus 16, which we see in choice B. Right, now we want to be careful here. It's not saying which of the following is equivalent. It's saying which of the following is not equivalent. So we can see that B definitely is equivalent. And that kind of gives us our answer because A is exactly the same as B, except it's got this minus 8x here, which is incorrect, right? We had negative 4x plus 4x should be 0. So since this one is not the same, we can go ahead and say with certainty that A is going to be our answer. But just to double check C and D real quick, if I multiply this 3 back in, if I distribute the 3 here, multiply 3 by x squared and 3 by negative 16, I get 3x. Well, if I can type it out, there we go. 3x squared minus 48. So we can say, okay, well, C is also equivalent. Right? These are the same as the original expression. D is probably going to be easier to actually work from the answer choice back and distribute the 3x and the negative 12 rather than trying to figure out how they came up with this expression. Really what's going on with this expression is it looks like they're sort of in the middle of factoring using grouping, but you don't really need to factor by grouping here. Instead, what I'm going to do is distribute both of these. That's going to give me 3x squared plus 12x minus 12x minus 48. And then the plus 12x minus 12x is just going to be 0. So we get 3x minus 48, which is the same as C. So all of these three answer choices, B, C, and D, are equivalent expressions to the original one. The only one that's not is A. But I do want to go back to sort of the easier way of approaching this, and that is just to pick a number, like 2, and plug it into x, right? You get this value. I think we said it was 36 or negative 36, something like that. And you plug in that same x value that you chose for this one, so whether it be 2 or whatever number you decide, and plug it into all the other x values. And what you're going to see is that B, C, and D are all going to give you the same number once you plug it in and throw it in your calculator, and A will give you something different for most x values. Now, if you choose an x value and they all look to be the same, then just pick a different one, and you'll eventually come up with one. It shouldn't take more than like 1 or 2 guesses to come up with one that's going to give you the answer. So anyway, that's all for number 12. Hey y'all, welcome back. Number 13 says, if the cost of carpeting a floor is $2.50 per square foot, how much would it cost to carpet a rectangular floor that is 10 feet by 12 feet? We have this rectangular floor, which is 10 feet by 12 feet, and I'm not drawing this to scale, obviously, but just to kind of get my head around what's going on here. Now, if I want to know the total area of this rectangular floor, to find the area of a rectangle, all you need to do is just multiply the two dimensions together. So in this case, 10 times 12, which would be 120. The total area here is 120 square feet. And it says the cost of carpeting such a floor is $2.50 per square foot. So as long as we know how many square feet we're trying to cover here, which is 120, we could just multiply that number by the 250, right? So if it's 250 for 1 square foot, then it's $5 for 2 square feet, and so on and so on. Basically, for each square foot, we're going to add $2.50. So the computation we want to make here is $2.50 times 120 square feet. Okay, so yeah, let's just go ahead and type that in our calculator here. Make sure we get the right answer, and I'm getting 300. So that's really all there is to it. Just make sure you know how to find the area of a rectangle. I don't think that formula is going to be given to you, but hopefully, this is pretty basic. Not that this saying this problem is basic, although it is kind of is, but this is actually talking about what kind of calculator you're going to be able to use, which is a 4-function calculator. Not that you need anything more advanced to do this problem. But anyway, our answer here is choice D, and that's about it for number 13. Hey y'all, welcome back. Number 14 says if n is the least of two consecutive odd integers, which of the following represents the sum of the two integers? So odd integers are going to be numbers that are whole numbers that are not divisible by 2. So we're talking numbers like 1, 3, 5, 7, 9. Really, it's every other number, okay, starting with 1. So if the smaller number is n, so the smaller number is n, then the next consecutive integer, and consecutive means if you have a list of things, if two items in that list are consecutive, that means they follow one after the next. So if I'm saying the next consecutive on integer, if the smallest one is, say, 7, the next one would be 9. Okay? But the key point is that the next number is going to be 2 more than the previous number. So the next number is going to be n plus 1. I'm sorry, plus 2. Okay, like so if the first one's 3, the next one will be 5. If one is 11, the next one's going to be 13, and so on. So it says, which of the following represents the sum of the two integers? So sum indicates that we want to add these two things together. So I have n plus this n plus 2. And when I combine my like terms, which is just the n's, I'm going to get 2n plus 2, and that's our answer. So we have our answer choice right here, letter D. And that's it for number 14. Hey y'all, welcome back. Number 15 says, well, it doesn't really say anything. It just has this expression, and we're supposed to simplify it, I assume. So really this just comes down to knowing your exponent properties. I might actually write that up, make a little note up here, is if you're not really familiar with these exponent properties, what I'm about to say and kind of my explanation here might be a little confusing. I'll try to break down each property as I go through it. But if you're not really familiar with these, you definitely want to go back and review your exponent properties. Okay, there's quite a few of them, and so it might be worth just going back and looking at those. And I would just, go into YouTube and type exponent properties explanation or anything like that, and you should come up with a pretty good video that sort of goes over each of the exponent. But let me show you how we would do this one. We've got x to the negative 5th times y all over y cubed. Okay, now I'm going to simplify this probably a little differently than you may have seen before, but hopefully it'll all make sense. So the first thing I'm going to do is try to rewrite this so I don't have a fraction. Okay, now the exponent property that I'm going to use here, and I'll just kind of keep track of them over here. First one I'm going to say is that anytime you've got a negative exponent, so let's say I've got x to the negative a exponent, so like negative 2 or something like that, I can rewrite that as 1 over x to the positive a. And so that's how you deal with these negative exponents. But what I'm actually going to do here, a little unconventional, is I'm actually going to use this property backwards and try to rewrite this so there are no fractions involved, at least not up front. Okay, so this y cubed is really like 1 over y cubed, okay? Y cubed's in the denominator. And so if I use this exponent property, that means I can rewrite this as y to the negative 3rd. Okay? And so what I'm going to do is just rewrite this, and instead of having this divided by y cubed, I'm going to multiply by y to the cubed. I'm sorry, not cubed, to the negative 3. Now another thing that I might want to point out here, this is another exponent property, is that anytime you have just a regular old variable here, that's the same thing as saying that variable to the first power. Okay, so if you don't see an exponent written, sort of an assumed 1 there. The next thing I'm going to do is try to combine these y's. Okay, so the way that you combine y's when you're multiplying, we call the product property. And again, I know I'm running through these properties pretty quickly, which is why at the beginning I said go look these up so that you can be a little bit more familiar with them. But basically, if you are multiplying two powers and they have the same base here, the way to combine them is you add the powers up. Okay? And so if I have y to the first times y to the negative third, I can add those up, and I get 1 plus negative 3, which is negative 2. Okay. Now we've got another property. Okay, and so yeah, this problem really requires that you know quite a bit about exponents here. And that is, I'm raising this whole expression to the negative first power. Now, I know we talked about negative exponents, but I don't really want to deal with that negative exponent yet, because first, I'm going to say that if I've got any product, so like say x times y, and I raise that to a power, that's going to be equivalent to raising each individual factor by that power and then multiplying those separately. Okay, it's almost, it's not the distributive property by definition, but it kind of works like the distributive property, like visually, right? So, you know, it's technically not an application of the distributive property, but it is very similar. Now, if I want to raise each of these to the negative first power, which is what I want to do here, I basically want to kind of like distribute this negative 1 to both of these. I actually need to know another property, and I know this is getting kind of ridiculous with the number of properties I'm listing here, but that's just the way it is. Okay, I'd rather give you more information than not enough. Okay, so the next property we are going to use, and I think this may be the last one we really need to call out here, is whenever you raise a power to a power. So let's say we have something like, you know, x to the a. Really don't want to put a number on here because I want to write it generally. And let's say I raise that to another power. The way you can combine these is through multiplication. Okay, so you just multiply the powers together, a times b. That way you get rid of this power to a power. And this is called the power of power property. Power to a power property, something like that. But anyway, at any rate, we're going to basically distribute this negative 1. We're going to raise each one of these factors to the negative first power. And since they already have a power on them, or an exponent, we're going to multiply those exponents together. So negative 5 times negative 1 is going to be positive 5. And negative 1 times negative 2 is going to be positive 2. And there we go. We got our answer here. So our answer is choice C. And that's about it for number 15. I would recommend going back and reviewing these exponent properties because you do have to be pretty familiar with them to get this one right. Now, if you're worried about not being able to remember all these exponent properties, and a problem like this kind of makes you a little uneasy, well, one thing you could do as sort of a fallback strategy is just to pick a value for x and y. And they could just be any numbers, maybe not make them the same numbers, but say like x equals 1 and y equals 2. And then just type this into the calculator, except with those numbers that you picked. And it'll equal something, probably some fraction or something. And then use those same x and y values to plug in here and all the answer choices and see which one gives you the same number as the original problem. So you can kind of, I hate to use the word cheat, but you can kind of cheat your way through this problem without knowing any of the exponent properties. Just realize that you can plug your choice of a number into x and y, compute this out, and do the same thing with the answer choices. I had a similar problem like this. I want to say it was like number 13 maybe, or no, maybe it was before that. Yeah, with number 12, if you watch this video, that was a strategy that we could use on this one too, where we just pick a number for x, plug it in, and then see which one's the same. And really, you could use this strategy for any of these problems where you're just trying to identify which expressions are equivalent. So anyway, here's the sort of proper way to do it, but also consider that other fallback strategy that we talked about too. That's it for number 15. Hey y'all, welcome back. Number 16 says Raina has 5 coins worth 10 cents each and 4 coins worth 25 cents each. I'm not sure why they don't just come out and say it. I guess they don't want to assume that you know what coins are worth 10 cents and what coins are worth 25 cents, but I mean, come on. Let's simplify this first sentence and just say that she's got 5 dimes and 4 quarters. Okay, the dimes are worth 10 cents and the quarters are worth 25 cents. If she chooses 2 of the coins at random, what is the probability that the 2 coins combined will be worth at least 35 cents? So as far as like what could possibly happen if you're just randomly picking 2 coins, they can either be 2 dimes, 2 quarters, or 1 of each. The only combination of those that will not be worth 35 cents is if we pick 2 dimes, right? 2 dimes, 2 10-cent pieces are going to be worth 20 cents. But if we pick a dime and a quarter, that gets us up to that 35-cent mark. So I think the easiest way to approach this problem is to kind of find not the probability that the 2 coins will be worth at least 35 cents, but to find what's the probability that we actually don't get that, and then subtract that from 100%. So let's calculate the probability of getting 2 consecutive dimes. Okay, so the probability is calculated by computing the number of desired outcomes divided by the number of possible outcomes. All right, this is how you calculate probability in general, just a simple probability. How many options will give you what you're looking for divided by how many total options are there. So if we want to find the probability of picking 2 dimes in a row, which is the only case in which you wouldn't get at least 35 cents, we will say, okay, well, the probability of getting the first coin to be a dime, since there are 5 dimes in this pile and a total of 9 coins, the probability here is going to be 5 over 9. Now, that's just the probability of picking a dime first. When we have these combined probabilities where the second event depends on the first event, you have to think about how many possible outcomes are you actually left with, right? So we pick 1 dime. The probability of the second one being a dime, well, since we've already picked 1 dime and we've removed it, there's only 4 dimes left, and there's only 8 total coins left. So on that second event, for the second coin, there's a probability of 4 out of 8, or a 50% chance. Now, this is a combined probability problem where we're not just calculating the probability of 1 event, but 2 consecutive events. And so the way that you combine these probabilities is to multiply them. Okay, so if I multiply these fractions, what this is going to give me is the probability of picking 2 dimes in a row. Okay, so I'm going to say times 4/8, which is really just 1/2, but I'm not even going to bother reducing it because these numbers are just small anyway. Okay, so let me make a note here. Here is the probability of picking 2 dimes in a row. And I'll make a little note here, without replacement, meaning we're not going to put the dime that we picked back. So 5/9 times 4/8 is going to give me, let's see, 5 times 4 would be 20, 9 times 8 would be 72, and we can go ahead and put that in, well, you know what, let's just, let's go ahead and reduce this, I think. So 20 over 72, what would that reduce to? I'll put that in my calculator here. 20 over 72 going to give me, let's see, both of those are divisible by, let's just do one at a time here. You know, forget the calculator. Let's just divide by 2. That'd be 10 over, what would that be, 36, and then divide by 2 again to get 5 over 18. Okay, so 5/18, right? And we can calculate that out of 100%, but really that's what we're looking for. Okay, so 5 out of 18 potential events are going to give us 2 dimes in a row. Now to figure out, well, we want kind of the other side of that, right? We don't care about, but the question here is asking, what is the probability that you get at least 35 cents? And so that's going to be all the other possibilities, right? There's a total of 18 total possible outcomes here, where 5 of them are going to be picking 2 dimes in a row. So the probability of picking 2 coins that will be worth at least 35 cents, and again, without replacements, is going to be 1 minus this. So in other words, it's going to be, well, all 18 outcomes, right? So this would be 100% of all the total outcomes, minus those 5 outcomes. That would be the 2 dimes in a row, and that's going to give us 13 possible outcomes. This is going to give us our answer here, 13 out of 18, which is going to be the probability of picking 2 coins that add up to at least 35 cents. Well, that's it for number 16. Thanks for watching, and have a great day. Hey y'all, welcome back. So number 17 says, in the xy plane, what is the y-intercept of the graph of the equation y equals 6 times x minus 1/2 times x plus 3? Well, this equation looks a little tricky, and you might be thinking, gosh, I'm not even really sure how to graph this or anything. How am I going to find this y-intercept? Well, luckily, finding the y-intercept is easy no matter how complicated this equation is. The y-intercept, just to kind of go over the vocabulary for a moment here, is the point on the graph where your graph crosses the y-axis. So that's that vertical axis here. No matter how crazy your graph is, if it does something like this, and this particular graph doesn't do anything nearly this complex, but let's just say it did. The point that we're looking for is right here, right? It's where it's crossing the y-axis. That's what it means by y-intercept. And the key thing to understand about a y-intercept is that no matter where the function crosses that y-axis, every single point along this line is going to have something in common, and that is that its x-coordinate is 0. So if you imagine like the point at the origin 0, 0, you have 0, 1, 0, 2, 0, 3. So wherever the y-intercept is, the x value or the x-coordinate of that point is always going to be 0. So the x coordinate of the y-intercept is always 0. I can't spell today. There we go. So how can we use this to actually solve this question? Well, if it's saying, what is the y-intercept of the graph of this function? This particular function, you might not know exactly what it looks like. That's okay. You don't get a graphing calculator. You don't need it. Okay, all you have to do is recognize that the x-coordinate has to be 0. So the strategy for finding the y-intercept is going to be to substitute 0 in for x, and then evaluate, or I'll just say solve for y, even though there's not really too much solving going on here. You're just going to evaluate. But yeah, this is going to work no matter how complicated your equation is. So whatever the equation is, it could be 10 times as complicated as this. All you have to do to find the y-intercept is just plug in 0 for x, and then figure out what y is. So here we've got y equals 6 times 0 minus 1/2 times 0 plus 3. And this says you get the square root calculator, so you get, I believe this means you get a scientific calculator. You don't even need anything that complicated, because all we're doing is just evaluating. So you could plug in this whole thing in your calculator. Honestly, you probably don't even need a calculator, although I would suggest you use it anyway, just to make sure you don't make an arithmetic error. But 0 minus 1/2 is just going to be negative 1/2. 0 plus 3 is going to be 3. Now we just multiply these together. So 6 times negative 1/2. Well, half of 6 is 3. It's negative. That would be negative 3 times 3 will be 9. And there we go. There is our y-intercept. It's going to be at 0, 9. So we see our answer choice. The correct one is D here. And that's about it for number 17. And actually, you can use this strategy for any question where it's asking for the y-intercept. Hey y'all, welcome back. Number 18 says the area of this triangle is 21. What is the value of x? And you can see this diagram gives you both the height and the base length here. So this is the height, and the height is just equal to x. The base here, which is the distance from here to here, is going to be x plus 1. So to answer this, we really need to know how to find the area of a triangle, and that formula is going to be given here. Area equals 1/2 times the base times the height. Okay, and just to be very clear here, A is the area, B is the base, and H is the height. I want to make sure I don't leave anything. I don't want to have any ambiguity here. Okay, so it says the area of this triangle is 21. What's the value of x? The area is 21. 1/2 times the base, which is x plus 1, times the height, which is x. Okay, so we're going to multiply these together. Okay, so now the question here is asking what x is. So you probably could get away at this point, once you set up this equation, with using your answer choices to figure out what the right answer is. I'm going to go through with you on the algebra on how you would solve for x here. That way, if it's, looks a little different, or if it's an open-ended question, you could still answer it. But here, at this point, what I would do is just plug in the answer choices into x and see which one gives you 21. So just like really quickly, like if x is 3, x plus 1 would be 4, right? So 4 times 3 would be 12. Half of 12 is 6. It's not 21. I throw in 6 here. 6 plus 1 is 7. 7 times 6 is 42. And half of 42 is 21. So we know what our answer is going to be here. It's going to be B. You could check 7 and 11 and see that they're not right. But I do want you to know that that is a solid strategy for answering these multiple choice questions. Now, I will go through the actual algebra here, but honestly, it's pretty overkill for answering this question because it is multiple choice. But, since I've got you here, and if you want to see how you would actually solve this for x, let's work through it. So first, I'm going to rearrange this. Multiplication has this property called commutativity, which means that the order doesn't matter. In other words, 2 times 3 is the same as 3 times 2. And so since I'm multiplying 1/2 times x plus 1 times x, just to make this a little easier to read, I'm going to rearrange the multiplication a little bit, and I'm going to move this times x over here. Okay, 1/2 times x times this. I really don't need these little dots here. I just wanted to show you how the commutative properties would play out here. I'm going to delete those. Okay, if you don't see a symbol in between a number and a variable like this, it's assumed to be multiplication anyway. So then from here, you would distribute the 1/2 x, you'd use the distributive property, and multiply 1/2 x to both x and 1. Okay, what we're doing here, just, I'm kind of going off in the algebra here, but what we're trying to do is rearrange this equation so that we can isolate x. And to do that, well, we have what's called a quadratic equation here, which means that we're going to end up with an x squared, which we're going to see here, 1/2 x squared plus 1/2 x. And yeah, so anytime you've got a quadratic equation, in order to solve that, you're going to have to set it equal to 0 so that we can factor and use the zero product property. Like I said at the beginning, like the algebra here is going to be way overkill for trying to answer this question. I would definitely recommend just plugging in these numbers to see which one would work. It's going to be way faster to do it that way. But anyway, here's how it would play out. In order to solve this, I do need it to be 0, so I'm going to subtract that 21 from both sides. That's going to leave me with 1/2 x squared plus 1/2 x minus 21 equals 0. Now the fractions I'm going to try to get rid of. Kind of annoying to have those fractions in there, and factoring will be way easier without them. So I'm going to multiply both sides by 2. Okay, so just to kind of show you what I'm doing here, I'm going to multiply this side by 2 and this side by 2. I'm allowed to do that because I'm doing it to both sides. I have these properties of equality that allow you to essentially do pretty much anything you want to the equation as long as you do it to both sides. Now there are some, special cases here and there where that doesn't work like that, but for the most part, you are allowed to do that. So when I multiply this whole thing by 2, it's going to clear those fractions because 1/2 times 2 is 1, and that's kind of what I'm trying to do here. I'm trying to make this a little simpler so I don't have to deal with the fraction. So yeah, I'm going to end up with x squared plus 1x. It looks like I'm going to be stuck with a fraction either way. Oh, no, I'm not. No, never mind. Okay, 42. Yeah, I just had a little brain fart there. Okay, so now we can factor this, and to factor this, we're going to find two numbers that multiply to give me negative 42 and add up to negative 1. That's going to be positive 6 and negative 7. Oh, I think I just, you know what? This is supposed to be plus. Sorry about that. That's going to make this minus 6 and plus. A little error there. Okay, there we go. So, yes, so two numbers that multiply to give me negative 42 but add up to 1 is going to be negative 6 and positive 7. Now I can use the zero product property, which allows me to set each expression, each factor rather, equal to 0. Basically what it means is that when you have two things that are being multiplied together, if it equals 0, then at least one of those things has to be 0. So either x minus 6 equals 0 or x plus 7 equals 0. You might be thinking to yourself, well, hang on, we're about to get two separate solutions, right? We are. Why is it just one of them? We'll see very soon why that is. Here, if I add 6 to both sides, I get x equals 6, which is what we knew the answer was from, like 5 minutes ago. But here, we get x equals negative 7. Now, sometimes in geometry, you end up, when you're trying to solve these geometric problems using algebra, sometimes you get what are called erroneous solutions, or sometimes they're called extraneous solutions. And basically what that means is it's a solution that you get from correctly working out the algebra, but because of some context or because of some reason, maybe it's a domain issue or something like that, or just the context of the problem, one of the solutions is just invalid. So for here, the negative 7 is going to be invalid because you can't have a height that's negative 7 units, right? It doesn't really make sense to have a triangle where the height is negative. So the only choice we really have here is x equals 6, and we see that that's answer choice B. I just spent, kind of a bit of time here working through the algebra. You can see that there's kind of a lot going on here. Really want to emphasize that you can kind of cheat your way through these problems. You don't need to know all this algebra to get this right. Just plug in the answer choices and see which one works. I mean, these numbers are pretty small, so it shouldn't, take too much time to do 1/2 times 3 times 4, 1/2 times 6 times 7, 1/2 times 7 times 8, 1/2 times, what was the last one? I think it was 11, but let me double check. Yeah, 11. So 1/2 times 11 times 12, and see which one ends up equaling 21. All right, well, that's about it for number 18. Hey y'all, welcome back. Number 19 says, for which of the following values of x is the function f of x equals the square root of 4 minus x squared not defined as a real number? So you might be thinking, well, if it's not a real number, what is it? Yeah, like what other kinds of numbers are there? So there's a whole nother branch of numbers called imaginary numbers. And these imaginary numbers come from trying to take the square root of a negative number. Okay, so this is really going to be the key point here. The square root of a negative number is not real. Okay, that doesn't mean it doesn't exist. It just means it's not real. You might be thinking of real like just in terms of what the English word means. But in mathematics, a real number is really just a classification of the numbers that are on the number line. Every number, whether it's an integer, like a whole number, or fraction, or even an irrational number like pi or the square root of 2, all of those are real numbers. It's on the number line, it's a real number. But square roots of negative numbers are not real. That's because there is no real number. There's no number on the number line that if you were to multiply it by itself would give you something like -1. Okay, so in order for this to be not a real number, this number underneath here needs to be negative. Okay, so I guess the easiest way to say this is what we're looking for is 4 minus x squared needs to be negative for f of x to be not real. Okay, so we have our answer choices here, and while we could set up an inequality and solve it, I think we've seen a couple problems like this where the algebra is just way overkill. I think we're just going to plug in numbers here and see which one works. So let's see what's going on here. So if I plug in -2, I'm going to get, well, if I can actually type something, there we go. We get 4 minus -2 squared. Okay. Now, -2 squared is 4, right? And 4 minus 4 is 0. Move this over a little bit. So this thing is just going to equal square root of 0, which is just 0. And 0 is on the number line, so it is real. That is not going to be our answer. I'm going to move this over a little bit here for you. Get too crowded in here. Okay, so yeah, so there we go. B, if we plug in 0, see what happens. So I'm just going to take all this and copy and paste this here. If I plug in 0 instead of -2, well, 0 squared is just 0, and 4 minus 0 is 4, and the square root of 4 is 2. So 2 is a number on the number line, so there, that one would be real also. That's not the answer choice we're looking for here. If we try to plug in 2, get 4 minus 2 squared. Well, again, 2 squared is 4, and 4 minus 4 is 0. So again, we get 0, another number that is real. Now, if we try to plug in 4, we've already, by process of elimination, have figured out our answer here. But if I try to plug in 4, I get 4 minus 4 squared. 4 squared is 16, and so 4 minus 16 would be -12. Okay? So this is going to be a non-real answer, okay? This is not real. Now, we could, talk for hours about, these imaginary numbers, which are the ones that are not real. There's a whole lot that we could discuss here, but I think really the key idea that you need to know to get a problem like this right is that when you try to take the square root of a negative number, you are going to get a number that's not real. So our answer here is going to be D, and that about wraps it up for number 19. Hey y'all, welcome back. Number 20 says, under ideal conditions, the population of a certain species doubles every 9 years. If the population started with 100 individuals, which of the following expressions gives you the population of the species years after the population started, assuming the population has been living under ideal conditions? So whenever you're trying to set up an exponential growth equation, which is what this is, anytime you're doubling or multiplying a value over and over again, you are working with an exponential function. And these are always going to be written in the form a times b to the x, where a is the initial amount. That's your y-intercept, essentially. And b is the growth rate. Okay, so in this case, the initial amount was 100, so we're going to start with 100. Okay, so y equals 100 times, and then we're doubling, so we're going to want to multiply this number by 2 over and over again. So that's going to be my growth rate. And there you go. There's our equation. Let's go ahead and look at our choices here. And we see that none of them look like this. Yeah, there's one that's close, or actually two that's close, this one and this one. We need to figure out what's going on here. Like, why is this not the same? There's an extra 9 in here, basically. Let's go back to the actual question where it says, it's actually not doubling every year. It's doubling every 9 years. This is kind of the catch here. So in order for it to double every 9 years, we need to divide this x by 9, okay, so that we basically are going to do 1/9 of the doubling each year. Okay, so if we double over the course of 9 years, divide that up into each individual year, if we do like 1/9 of that doubling per year, so maybe I can try to illustrate this. So if here is our timeline here, right? We want to double over the course of the full timeline. So we're going to start with 100. Start with 100, and we're going to double all the way to 200. Right? This is going to take 9 years. So if I split this up, say, okay, well, if I'm doubling every 9 years, here's after year 1, year 2, 3, 4, 5, 6, 7, year 8, and, well, this year 9. I didn't really space this out very well, but there you go. Okay, so the point that I'm trying to make, well, it's not going to let me just drag one line. Are you kidding me? Okay, that's okay. What I'll do here is just make this a little smaller, so it at least looks a little better. Okay, so the point here is over the course of 9 years. Okay, so this is year 0, year 1, 2, year 3, year 4, year 5. Get some crooked lines here. Year 6, year 7, year 8, and year 9. And over the course of these 9 years, you get one full doubling. Okay, so it doubles. Okay, so in order for us to keep track of each individual year, we need to notice how we broke this up into 9 pieces, one for each year. You know, from 0 to year 1, we don't do a full doubling. We only do 1/9 of the doubling. And then after year 2, there's 2/9 of the doubling, 3/9, and all the way till we get a full doubling. So in order for us to get that exponent right, since it doubles not every year but every 9 years, we're going to say it's x, or in this case t, we're using t here, divided by 9. And that's going to be your answer, which is, let's see, letter T. And yep, that's it for number 20. Thanks for watching. Y'all have a great day.